So I want to believe that you can see my screen and we can start. Last week we started with control structures, and we talked about 3 of the control structures. We talked about procedural control structures. That procedural control structures are just the logic with which your program flows, from one step to the other. And we discussed that naturally, it just makes sense to usually before you start writing even the first line of code, especially when you're working from a software design paradigm, it just makes sense to outline the procedure that your code will go through inside a flowchart or pseudocode. All right. So that way it helps you manage the procedural requirements and help you set the procedural control structure so you know what will come before the other, what steps they will flow with, and all of that. We also talked about decision control structures, which happen when you have to make a decision. So there are a lot of times when in the course of building your app, your programming logic will run into a place where they have to make a decision. So in Python, there is basically just one decision structure: if, else, or if, elif. All right, we're going to look at all of these in more advanced details, as the class goes by. Then there are loops. What are loops? Loops are when you have to do something repetitively. Now, there are 2 kinds of loops. There are the loops that you know how many times you want to repeat it. All right, you know how many times you want to take the action, but there are some that you do not know how many times or how long you need to do that action. For example, if you get home and your child is sleeping, you don't know how long it's going to take you to knock before that child wakes up and comes to open the door. So if you were to write a program that was going to control you, when it gets to that point that when you get home and the child is sleeping, you just keep knocking infinitely until the child opens the door. So that's how it works in programming. That the second kind of loop is the loop that you know how many times you're going to do that thing. For example, if you're taking drugs, you know that your drugs, your medications, you're going to take them like 3 times a day. So 6 p.m., 12, 6 a.m., 12 p.m., 6 p.m. So you can build a loop that for every 6 hours, take 1 dose of this medication. So that's how it works. And those are the things that you have to do. You implement them in your program. All right. So those are the Python is very, like I said, Python is a very lazy language. So unlike other programming languages where you have different choices for loops, in Python you just have 2 types of loops. While loop to take care of infinite loop sequences when you don't know how many, let me know it's infinite, let me use undefined, because infinite means it just goes on infinity. But undefined means that you don't know how long you need to execute the action before it needs to stop or before the result you're looking for comes. But for loops are used for definite actions when you know I have to do this 3 times, I have to do this 5 times, or I have to repeat this 7 times, or do this action over so number of times. So that's just the difference. And in Python, we really do not have any other options. So there are some people who come from other languages right now who are trying to force Python to adopt some other kinds of loops. So in Python 3.10, I heard there is now a switch statement. It didn't used to be there before, but they just released it. So the guys from other languages are winning, but it's not like it takes away the simplicity that Python is known for. No, it just gives some more option, so that Python looks as inclusive as ever. All right, so that's how it works. Now, we are just going to introduce functions, and from functions we'll come back to decision and looping because they will now have to implement some functions, So if time permits us, we will do all of this. All right. So somebody unmuted themselves. If you want to say something, you're welcome to say that. Okay. Okay. So all right. So since nobody's saying anything, I will just assume that we're all good to go. All right, so let's proceed. Now, just a second. I need to confirm something. Okay, I just need to send a message to someone to join this class. I remember that I was supposed to send a message. I just remembered now. Just a second. Okay. All right, so sorry for that break in transmission. I guess I get to get this out of the way. All right, so let's go talk about functions. Then when we come back, we will talk about control structures. Now, when you hear functions in Python, don't let it phase you. A function is just a bulk of or a chunk of code that does something. All right. And a function has 4 parts, basically. Every Python function has 4 parts. The first part, which is the definer, usually a def keyword. That's how you know it's a function, all right? The second part are the arguments or the parameters that the function would require to work. The third is the body of the function, which is the block of code that you need the function to execute. And then the fourth is what the function should do after you run that block of code. So those are the 4 parts of what makes up a Python function. So let's take an example that will bring this home. Now, let's say when I say you want to do anything in Python, I mean anything in Python, whatever you want to do. For example, last week we did an example of a shoe size calculator. All right, you can execute that in a function. So what I'm going to try to do right now is to just create something. So I do not remember my math formulas very well, but I think that the area of a square is of a rectangle is length times breadth, right? Yeah, length times breadth. So let's say we want to write a function that computes the area of a set of a rectangle length times breadth. Now, one of the good things about functions is that we write this function so that any other person that needs to calculate length and breadth does not need to come and start rewriting the function again. You can just copy your code and run it, and it will run. All those libraries that you see, pandas, numpy, and all of that, they're just a bulk of functions, a bunch of functions that have just been written and wrapped together in a library so that anytime we need to do something, for example, we want to create a pivot table or we want to bring in data from CSV file or something, we don't need to go and start writing our own code again. We just need to call that function that has been created inside of pandas and packaged inside the pandas library, which is called read CSV, and we're good. So remember, this is a live class, which means you can ask questions anytime. Don't worry about interrupting the recording. This is we are more into you who are live with us than what anybody who would watch the recording later thinks about the class. All right. So feel free to interrupt at any point in time, ask any question you want to ask. The class is for you. The recording is just for people who would miss it, or in case you want to just view something much later. All right. So now let's create a function that calculates the area of a rectangle. So I told you the first part of a function is the definer, which is the def keyword. So I'm just going to say def. All right, let me increase this a bit so that it's more legible. So def, that's the keyword. Then the next thing is what the function is supposed to do. So let's call the function area of rectangle. All right. So the next thing that we're going to do is the function or the parameters that this argument requires. So we're going to put it inside this bracket. So we're going to tell Python that this stuff requires two arguments, which is length and breadth. Now, one thing you must note in Python is that anything you put inside here are just placeholders. I can decide to even just remove this L and B, all right? I can decide to write anything inside of that place. They're just placeholders. So the fact that I put length and breadth here doesn't really mean that it's something very prestigious. It's just a placeholder to tell Python I'm expecting two variables, two arguments or parameters, if you like. And that's the first one is the parameter length, and any value that is inside the second time, right? And any value that is inside the second place in this bracket is the parameter breadth. All right. So that's basically what this is. Now, when you press and when you're defining a function or you're defining an if statement or you're using a while or whatever, whenever you finish, you must use a colon. All right. And once you use a colon, Python automatically knows that, hey, the next lines of code belong to this thing. So when I start typing, you will notice that Python has automatically created an indent for me because it's making this chunk of code, you know, run with this. If Python removes this indent here, this chunk of code will no more run as part of this function. And that's one of the things that disturbs many people that come from other programming languages, because in other programming languages, this white space is not a problem. But in Python, this white space is a major problem. If you don't have it, your code will not run. So you always have to make sure that the indent is on point and, you know, as required. So the body of the function is I can just decide to write it like this: area, which is, I'll now say length times breadth. Then, so now this is what my function does, all right? So I've gotten my definer, which is the def, the keyword. I've gotten the function, which is the arguments. This is the argument. This is the arguments, the length and the breadth. I've gotten the body, which is this. And then the last thing is the result. What should a function do? So there are different things that a function can do. And as we advance in these Python sessions, you're going to be seeing them. So the first thing a Python can do, which is the most common you would have seen, is to return the value of what is calculated. All right. Another thing that Python can do is to print. Another one is to yield, but you use yield when you're dealing with generators, iterators, and all of that. So there are different keywords, but these three are the most popular that you would see that usually end every function. So let's tell this Python function what to do. Return area. So remember, we have the definer, we have the function name, we have the arguments, then the body of the code, and then the results, what we want Python to do. So now, when we run this, Python tells us, okay, your function is good to go. How do you use a function? You call that function. So this is how you call the function. Area of rectangle, all right? And then you open a bracket. Now, because there are two parameters inside of this bracket, what Python expects from you is that this bracket is going to contain two parameters. Anything short of two, it's going to give you an error. So let's say we are working on a rectangle that has this 5 by 6 meters. All right. So this is the length is 5, the breadth is 6. Okay. So when we just do this and we'll just run it, Python will return the value of that function, which is area. And area is what? Length times breadth. It's very simple, right? That's very simple. So that's basically how functions work. Now, some other times functions can have very long block of codes. For example, this birthday, this shoe size calculator that we had, we can actually make it a function. All right. So we can actually just copy it, paste it here. But then we'll have a lot of indenting to do, because when we call that function, which is def find birthday, or let's just call it birthday calculator. And then we'll tell Python the parameters we expect it, to have. So the parameters are shoe size, as birthday, and the year of birth. So let's have shoe size here. Comma, has birthday, and the year of birth. Okay, so when we do this, as usual, we'll put this here. Then we begin to indent. All right, so we'll have to make sure that all the lines of code fall into the same indent space. So, sorry. Just have to keep doing this. If not, then we would have a problem. So, sorry, let me get this. Okay. Else results equals this. Okay. Almost there. It's there. And with great. So now let's run this. So Python knows that this is a function. So when we want to now calculate this, all we just need to do is to just say, if somebody wants to, run and find their birthday, all the person just needs to do is just to say birthday calculator, and then he will now supply the parameters. All right. Now, so with that, we will now have to remove these inputs that we have here. So we will remove this because the person will supply the shoe size. We will remove this because the person will supply the birthday. And we will remove the year of birth because the person will supply that. Okay. So let's use shoe size 10, has birthday true, and year of birth, let's say 1975. And now let's run it. Hope it doesn't give an error. Okay, so shoe size, let me see, 10. Birthday, true. Year of birth, 1975. And then, yeah, okay, so somebody unmuted themselves. Please go ahead. Let's hear your question. Tima, that will be you. Yes, please go ahead. Tima, we cannot hear you.
If maybe I should go first since you can hear her.
Okay, please go ahead.
So I think it shouldn't ask you to enter the show size again since you removed it from the function. Maybe you didn't run the function again.
Yes. You know, that's why it asked me. So now if I run this function like this now and I do this, you can see I was hoping that somebody would notice it.
Of course I do.
Yeah, so it's because I didn't run the notebook after I deleted that. So you guys are improving. I'm glad, I'm happy. Okay, I'm sure it's the same thing Tima wanted to tell me. So yeah, so Tima, you can type it in the chat. You can type it in the chat and then.
Hello.
Yes, please go ahead.
Okay, I wanted to say the same thing, but also we could also define the function and not put any parameter inside.
Okay.
So that it's not ask us for input too. That's if we have
if you have those inputs. Yes. So if you have those inputs,
so we can define it and leave it blank with the bracket and then just call it and then it will not ask us. Because if we are defining it for somebody, if we're defining this for somebody, the person may not know what his birthday is. So it's all those are input that really define it, that will now help the person. Is you now that know that, because see, this has birthday. If someone is seeing it, person does not know what the function is. What is has birthday? What are you saying? What are you talking of?
Now
With the
yes, I get you perfectly. Go ahead. Okay, go ahead.
No, I'm done.
Oh, you sure? Okay, cool. Okay, so I'm going to show you a trick that you can use to do that. Now, because when you start looking at some very intense Python functions, you might not even understand what the person is doing. All right, so let me call this birthday calculator 2. So that's it's clear. Okay, so this is year of birth. Now, with starting from Python 3, I think it's Python 3 points. Yeah, I can't remember 3 points what it is. All right, but you can actually do this. You can say shoe size, all right? And you define what you expect. That's one, whether it's an integer or whether it's a string or whether it's a float. And like this one now, you can define it to be string. And then this one, define it to be an integer, all right? So already Python knows that when he says this, okay, I'm expecting an integer, string and all that. But this one is just for show. The main thing that you are expected to do after every Python, in fact, the Pythonic thing after every function you create is to create a docstring, something called docstring, all right? So what is a docstring? A docstring is a text that tells everybody, number one, what that function does and explains the parameters that are required in that function So in this docstring now, I'm going to now start explaining. How do you do a docstring? Just 3 inverted commas, all right? It can be 1 set, it can be 2 sets. Whichever one, as in it can be the single quotes or double quotes, or make sure there are 3 in number. So when I do this, I can now say this is a function. So this is where we'll put the documentation, all right? Let me just put, that's why they call it a docstring. It shows the documentation of a function. So this is a function that helps you calculate your birthday, all right? Docstrings allow multi-lines. So you are to supply 3 variables or 3 parameters, let me use that word. All right, shoe size, etc, 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 etc. So by looking at the docstring, all right, anybody who is coding already just knows, oh, hey, this is what shoe size is. It's an integer, you know, stuff like that. All right, so that's how it works. This can also work. If we run this now, you'll see that it will work. So we can now do def, sorry, we can now call this function birthday calculator 2. All right. And when we run it, it asks for the shoe size, which is, let me use 10. Asks for the birthday, which is true. And then it asks for the year of birth, which is 1975. And we have the same result. So that's basically how this function works. So you either declare the parameters explicitly, all right, and then, or you do not declare the parameters. Now, there are some times that you can run into some functions that can phase you. For example, some people might want to, you see the same function that we did here, area of a rectangle. Some people might just declare it like this. Area of a rectangle, and they won't declare anything here, all right? Then they will come here. So let me just call this area of a rectangle 2, so that to differentiate this from the first one. They'll come here and declare the length, all right, to be equal to, what will that be now? Length will be, I'm trying to get the right way to do this now so that it doesn't look very clumsy. Okay, so length can be an input, just like we had the first one here. So input int, all right. And that would be something like this, enter length here. Then breadth will also be another integer input, and you have enter breadth here. Okay, so we can close this. All right, suppose. So when you run this, then if you call this function area of rectangle 2, it will start asking you for inputs. So enter length 12, enter breadth 12. So your area is 144. But there is also another way to go about this. You can just do it like this. The area of, sorry, let me call this area of rectangle 3. And then just put args here. See, args. And now, you see, this is where it becomes a bit clumsy. Not clumsy per se, but it can be very, if you're not careful, you'll miss it here. So follow the explanation very carefully. So this is it. When I use this word args, remember I told you that anything you put inside of the brackets when you're declaring a function is just a placeholder, all right? It's not, it doesn't have any value until a variable is assigned to it. So this args here is just a throwaway variable. It's just to say, okay, Python, I don't know how many arguments a person might want to put here, but whatever the person puts in here, I want you to multiply all of them, all right? So let me not use area of rectangle. Let me use ages of people in class. So ages of class people. All right, so the people in this class right now want to know their ages. Now, right now, there are 6 people in this class, all right? But while we're even populating the function, like 10 more people might just join, making 16. So we don't have those figures up front, you know, to say, run this thing for us. So how do we tell Python that we don't know how many people we are trying to calculate their ages for? As many numbers as they put in here, just multiply it. So this is how we do it. The first thing we do whenever you are doing a function like this.
Please,
Yes.
before you continue,
Please go ahead.
is it only for multiplication that it works?
No, it's not for multiplication. It works for addition, it works for subtraction, it works for everything.
Okay, because you said if we are putting the ages to multiply.
And we want to, oh, sorry, addition, we want to add up the ages. Well, we can also multiply the ages of people in the class. We can do anything to that, all right? So let's even use addition. So let's add the ages. So now, whenever you want to, okay, and this is where, if you have a background in C++, Java, or some other programming language, you would appreciate what I'm trying to do right now, because most of those languages are very manual languages. So the way they run is that before you instantiate a variable like this, especially when you're doing a for loop or something, you must begin with a counter. What is a counter? A counter, remember I told you the computer doesn't have a memory of its own. So the computer needs you to put whatever it is inside of its memory through a variable. So look at this. Now, a counter would be something like, let me just call this ages or sum of ages, all right? Because that's what we want to achieve, all right? So we want to have it as a 0 first, because we are just starting. So we're telling Python, hey, right now from the scratch, just assign this variable sum of ages 0, so that we know that that's where your counting starts. Then the next thing we're now going to do is we're now going to tell Python, now look at all of these things inside of this variable called args, this placeholder. So, well, this inside of this bracket can be the name of the ages of 6 people, can be ages of 7 people, 10 people, and all of that. But hey, that's what we want to do right now. We want to just, you know, okay. So let's tell Python what to do. So we'll now tell Python for I, and now this is another thing that you have to be careful of. This word I is nothing. It's just another placeholder. All right, Python is full of placeholders. So you can always replace them, you know, interchangeably. So, but most times the convention is to use I. So, but they say for I in args, all right, what should you do? The value of the variable called sum of ages will now be equal to what is there, which is sum of ages plus I. So we're telling Python that start from the first, and that's what that for does. Okay, let me explain the intuition behind a for loop. So let me say the people, let me just use this variable, people in class today. So people in class, let me use names John, okay, data and Tina. All right, let me see. Okay, so yep, so that's the 4 folks that we have right now. And now this is it. So if we want to use a for loop to loop through this, we can now say for I in this variable called people in class. All right, what should Python do? Print I. So I'm just telling Python for everybody, as you are looping through this iterable, just be printing their names one by one. That's what this for I in people in class does. So this is it. Print I. Oh, sorry, it's supposed to be in a bracket, a parenthesis. All right, so it tells me John, okay, data team. I just print them. Like I told you, I can change this to say for name, as in for every name in people in class, or for person in people in class, you know. So for person, in people in class, print person, and I'll get the same result. So that I is just a placeholder. Don't let it phase you. Don't let it worry you. If it confuses you, especially when you have a lot of code. Like for me, what I do is that when I have to write a very long line of code, I don't use I use the variable that I'm trying to iterate. That's the iterable, just to remind myself to, hey, okay, so this is what you're trying to achieve here. All right. So yes, please go ahead if you have a question. Please go ahead if you have a question. Okay, so in the absence of any question, I will just comment this out and comment this out. All right. So this is the variable. Now we're not trying to say, okay, so for all the people in class, for all the args here, all right, go and add the value that you just picked from here to the sum of ages. That's one. And then now update this sum of ages to that value. So that's why we did the sum of ages equals to sum of ages plus 1. So we're just trying to say the new sum of ages now will now be sum of ages plus the I that you just collected. So let's run this. All right, so now let's call that ages of people in class. So I'm going to donate ages to you right now. Okay, I'm donating 50. Tima, 55. Data, like 70. Let me see. Okay, John. Okay, let's give John 40. And then let's give Ademola like another 70. All right, so once I run this, oh, okay, yeah, I didn't tell Python what to do. That's why I didn't do anything. So here, return sum of ages. All right, so this is it. Now let me. So now I'm going to run this and bam. So this is a sum of ages. 50 plus 55 plus 70 plus this gives you 255. So what if I now say, okay, while we were calculating this, one person left the class, so remove their age. It gives us that value. Okay, another person has joined. In fact, another 3 people has joined. They're aged 10, 11, and 12. It gives us the value. So it helps make your functions a bit dynamic, so that, and this happens especially when you get to start writing advanced functions, you will now begin to appreciate why Python has this flexibility, because somehow you can even now start, you know, writing Python functions that create their own parameters, you know, inside of another function. Because in Python, functions are first class objects, which means you can use a function inside a function, inside another function. All right. In fact, there's another topic we're going to look at much later called decorators, how to use a function to decorate another function, and like that. So it's usually crazy. And yeah, many people usually like this part of Python functions. All right. So that's what you do when you have many arguments. Please remember, you can ask any question at any point in time. So if you do not stop me, I will just assume that everything is fine and that we are good. So should we go on, or you want to ask a question at this point in time?
Yes, I have a question, sir.
Please go ahead.
In the last code you ran.
Okay, this one?
This
Ages
one,
of class.
yes.
All right.
Yes, so let me see the code.
Okay.
Let me see the code, sir.
So this is
Okay,
the code
you
here.
said you divide ages of people, but multiplication is there.
No, this I told you this variable is a throwaway variable, is a placeholder.
Okay.
This star in front of it is just to tell Python that you can have many things. That's that multiplier there. You can have many arguments. Yes, you understand?
Okay, I was thinking it was for multiplication.
No, it's not for multiplication. It's to tell Python that there's a multiple of args there. All right, there's a multiple of arguments there. Yeah, so that's basically what it is.
Okay. All right. Thanks.
Yeah. Okay. So now let us do another example of functions with multiple arguments, but this time let's use a multiplier. All right. So let me create another function here. And this time we want to know, okay, what is the, let me see, multiplier. What can we multiply right now? Let's multiply. Okay, so we want to multiply. Let's say we want to multiply the. Please, somebody give me something to multiply. I'm running blank here. Nobody? Okay.
Let's maybe area of a triangle.
Area of a triangle. Okay, so area of a triangle, but that one is definite. It has 3 sides. We know it has 3 sides. A triangle can have more than 3 sides. I'm just trying to say, okay, let's multiply. Okay, let's even use the edges again, or let's use something else. Let's multiply the height.
Or maybe squares of numbers.
Okay, we can use that, but let's use something very simple. So let's say height multiplier. All right, so let's multiply the heights of the people in this class. All right, but again, because we don't know how many arguments are there, we just tell Python expects a multiple of arguments. All right, so that's why we have that there. Now we will now define the multiple. All right, so we can call this multiples or age or height multiples. So let's just call this height multiples. All right, now that's the variable that we want to get. But this time now, remember when we were doing the addition one, we started from 0 as our counter. This is the rule. When you're creating a counter, if the task that counter is to handle is an addition or subtraction task, that counter should usually start from 0. All right. But if you're creating, okay, yeah, I'm going to explain Args, Victor. I'll explain that shortly. Okay. So, but if you're creating a multiplication like this one, if you start from 0, you get an error because anything multiplied by 0 is 0. So whether you're doing multiplication or division, your height multiples or whatever it is, the counter must start from 1. All right. So that's why we're going to initialize our counter at 1. Sorry. So now we will now say for I, or let me say for height in args. All right. Python, what should you do? height multiples. All right. Sorry, this is supposed to be an underscore. Multiples, okay, should be updated to the first, that's the initial value, height multiples, multiplied by the height of the person that you're evaluating at that point in time. All right, so it's, remember, this is the, for every height that is inside the argument multiplied by this height, but this is one point where we could use I. So for I in args, multiply height multiples by I so that the function looks readable. Then we tell Python to return the heights multiples. And we run this. And now let's call this function. So call this height multiplier. Then let's say the first person's height is 12, the second person is 3, 5, 6, 7, 8, 9. Python gives us the value of all their ages multiplied. But let's say 2 people just left the class. So that's how it works. It's whenever you use this args, Python says, okay, I'm flexible, you know. Now let's go to quarks because somebody asked that in the chat. So what's the difference between args and quarks? Now, whenever you see a function like this, def, let's use, what is a good dictionary now? Okay, let me use, let me still use the, what do you call it now? Let me still use the, okay, let's use area of a rectangle, all right? Or let's even use perimeter of a triangle. So yeah. Now, okay, so let's call this function perimeter of, let's say the shape, we don't even know how many sides it is, so that we don't confuse ourselves. Let me say unknown shape, all right? So, because since we're trying to make the function very fluid, we can allow any number of sides. So the function, we don't know how many sides the shape has. So now, what is the perimeter of the unknown shape? Let me use the word quarks here. Star and quarks. So when you see quarks in Python, this KW is actually keyword, all right? So you're telling Python, what you should expect here is a keyword as an argument, not just any word or anything. Expect a keyword, all right? So that's what you're telling Python when you use quarks. Expect a keyword. Okay, so now, what that also means is that this variable here is going to generate a Python object that uses a keyword to refer to the variable. Among the 4 key Python objects that we have, which one uses a keyword to refer to a variable? We all know what the answer is, right? It's a dictionary. Great, you guys are very brilliant. So what that means is that right here, Python is expecting, okay, you're too much, right? So yeah, it means right here, Python is expecting a dictionary. So now, what happens is this. Remember that, okay, sorry, I'm supposed to put a colon here, all right? So remember that right now, we do not know how many shapes that we are trying, but we're trying to know the perimeter. So perimeter is length times breadth, if I'm correct, or length, all these sides, all right, the length of all the sides multiplied by each other. So let's assume that the object that we are trying to find their perimeter has 7 sides. Okay, let's use 4 sides. Okay, 4 sides, just so that we can have names to call it. All right. So somebody just unmuted themselves. You have a question? Okay, okay. So no question. Now let's go straight back into our function. All right. So now let's, as usual, whenever you have an undefined number of arguments, you have to start with a counter. So let's call this counter perimeter. All right. And then because it's a multiplication, as usual, we start from 1. Okay. So that's that. Now, the next thing we now want to do is to tell Python, because remember, when you're creating a dictionary, every dictionary has 2 parts. The key, which is the variable name in quotes, and then the values, which are the values that key opens. All right. So every dictionary has 2 parts, and that's what you're going to tell Python here. For key stroke value, because the first part of the dictionary is the key, the second part is the value, in quarks. So you're telling Python, this keyword arguments, I want you to break it into 2. The key and the value. Now, this is what I want you to do. I want you to make perimeter, which is this perimeter we're trying to do here now, all right? I want you to make it the perimeter that was there before, all right? Multiplied by, remember, you can't multiply by the key because the key is just, you know, like a placeholder or the variable name. You multiply by the value because that's where the number is, all right? So multiplied by value. Okay. So then we tell Python return perimeter. All right. So let's run this. Okay. So let's assume now that we have an unknown shape. All right. That has, so let's call this perimeter of unknown shape. So now let's take, let's say the first part of a triangle is the hypotenuse, the second part is the opposite, adjacent, and all of that. So let's even just put the numbers first. So let's say the hypotenuse is 3, opposite is 4, adjacent is 5, and then let's say one more part of the triangle. Let's call that the cosine length, anything, just want to call it, just nonsense, all right? So let's say that is 6. If we run this, we're going to get an error. Why are we going to get an error? Why? Because Python is saying that it cannot unpack this object here. Because we told Python, expect keyword arguments, which means expect like a dictionary, expect something that has keywords, all right? So it means that we must put keywords here, something like this to say, okay, Python, this is opposites, all right? Equals to 3. This is adjacent, equals to 4. This is hypotenuse, equals to 5. And then this is cosine side. This is equal to 6. Now, when we do this and we run it, okay, you know what's going to happen? Let me just take this to Google Colab and try to run it. And let me see what is happening. Let me use this new notebook, just so let me just paste this here for key stroke value. All right. In quarks.items, let me use quarks.items because I need the 2. Since I'm referring to the 2 of them, key and value, perimeter would be equals to perimeter times value and then return perimeter. All right. So let's see what happens here. Let's see. Let's hope there's no error. Oh, see, there is no error. Now let me run this and let's see perimeter. Let's see perimeter. Sorry, what's happening here? Unknown shape. All right. So let me see if Colab is going to tell me, okay, keyword arguments. All right. So let me put opposite equal to 3 and adjacent equal to 5. Now let me run this. Got an error. Okay. Now I used this same thing in a code some time ago. So allow me just copy the code and just paste here.
Sorry, how did you just use this Google Colab? Does it have a Jupyter Notebook inside?
Yes, it does. It's actually Jupyter Notebooks that is hosted in your Gmail account.
Oh, so if you go to Google Colab, it will ask you for the type of.
For
How do I get to use it on Google Colab? How do I get to run codes on Google Colab?
nothing. Just type the name of the just type that collab. You can just Google search it. All right. And once it comes out, just click on it. It's if you have logged into your browser with your Gmail account, then you'll be fine. Yeah, you'll be fine. To just connect you automatically. Okay, so now let me run this line of code and let's see if it brings a result. So what do you notice? It's running. Oh, I see my problem. I see my problem. Do you see how just one thing is going to mess you up? Do you see
yes.
how? You see just you see how, because I knew I used this thing in a piece of code the other time, and oh no. So that has been the problem, because right now when I run this, because I use this tool, it ran. So let me come back here and run this one, and it should run. Sorry, just a second. Okay, so here I will just double the steric and run it again, and here we will just run this. Let's see. Just want to make sure there is no unnecessary white space that is threatening. Oh, finally, it runs. Now, do you notice something? And this is one of the reasons that I usually.
Before you continue.
Okay, go ahead.
So that means to create the dictionary in these Quarks, you have to just do the variable assign operator, the variable assignment operator.
Yeah.
That's the single equal to.
Yeah.
So we're not using colon like we're creating dictionary.
No. We are not. And that's the thing. Now, if you use that, will it work? I don't think so. Let me see if that will work. Because if we do this, sorry, let me just copy and put inside another line of code. Okay, so if we put this here and we change this to dictionary, and we call this opposites. Opposites, and this becomes 3. Sorry, let me just make this opposites 3, comma, then there is adjacent, and this is 5. So let's run this and see if it works. It might just work. Let me see, invalid syntax. Okay, so it doesn't work. See.
Okay, sorry, and I know.
Oh, sorry, it might work. Let me just I didn't close the brackets. Let me see, it should work. Oh, come on, what kind of brackets did I use? Look at me. Okay, don't worry, we'll take all the questions. Let me see. It takes 0 position argument, but 1 was given. Okay, so I think it doesn't work. So
Okay, I'm saying
yes.
the opposite, the adjacent, it's not, you did not put it in a string.
No. Because this becomes like a parameter name. You know, if you want to, for those of you who know how to use like pandas already, let me use pandas here. So import pandas as PD, all right? And let's say I want to read a CSV now. So pandas dot read PD, let me use PD dot read CSV. So let me just, I don't know what's happening to this. Let me call this a data set and let it be equal to pd.read CSV file. All right. Now, if you look inside of this, you'll see the keywords that is required. So you can see delimiter equals to none. So that keyword there, that delimiter is like the keyword, the none is the value. Do you get? Do you get? Okay, are you there? Okay, I think Oge has dropped. All right.
I'm here.
Oh, okay. So that's what it does. Yes, Victor. Victor, the implementation is everything multiplied by everything. So if we add one more, if we add something more here, let's call this hypotenuse. All right, and then let's make it 7. And when we run it, it will automatically multiply that.
I'm not still clear with the pandas 3 CSV that you said. Okay, don't worry.
Okay, no, look at this. Look at this. If you try to get the parameters inside of this, okay, let me look for this. Let me just go to my desktop and grab a file from my desktop. Just a second. All right, so here it is. Now, I want to read, let me not use read CSV because this document is Excel. So let me say read Excel. Now I want to read this document. The name of the document is, this is the file part of the document. I just copied that now, come on. Okay, so let me paste the path here. So that's the path to the document. All right, now, the sheet that if you look, you will see a box of parameters just opened, right? Can you see it? Okay. So you would see one parameter asking for sheet name, which is this equal to, and then I will tell Python that the sheet name is equal to sheet1. All right. So this is what it was expecting here. This keyword and the argument that is attached to the keyword. So when I run this, it's, where is that? There is no such file for directory. I don't know what you're talking about because it exists. Oh, this is not, don't mind me. This is collab. It's not connected to my system. So because of that, it's not reading it in. But if I read it to in my Jupyter notebooks that are connected to my system, then I can always print data sets dot head, and yeah, it will come out. So that's the thing. But I'm just a bit I'm trying to find out where, because if I pick this now, you see this now, I'm going to pick this, copy, and I'm going to come to my, okay, so this is the data set, it's written. So you can see the parameter here, that's the keyword, and this is the value. So that's what that means. Now, if I paste this here, all right, and I run it, it runs. Now, let me go pick this here and run it here. So, okay, so it's running. So that's it. Sorry for the whole rigmaroling. Okay.
It's better we even had it. It's better. Please, can you come down to that panda side?
Yes.
Sorry, pause there. So it's still not clear.
Okay,
It's
not to worry.
I'm saying I don't understand why. You know, when you're assigning variable,
Yes.
we would not assign any variable here.
Okay.
And if you are creating a dictionary,
okay,
all these opposites and all would be in string.
yes.
But
I would, you know what? I'm going to, I would explain this.
So we didn't put it in strings. You just wrote it, and there was no other place it was defined earlier.
Okay. I promise you I'm going to explain this. In fact, in the next class, if I don't explain this, please call me back to it, all right? So I assure you I'm going to explain this.
With the pandas, you're still doing string and then assigning. Like if you go to that pandas, you still said wrote
yes.
sheet name. This is like a variable now. This is an assignment stuff. Okay. But in that one, there was no assignment.
There was. That's what I just did here. That's hypotenuse equals to 2. That's the assignment. You get. Opposite equals to 3. I just said equals to 5.
Does not know hypotenuse and opposite.
Okay.
It doesn't know the hypotenuse and opposite. And those are the keywords. Are they not?
No, you know, those keywords, I am going to supply them myself. All right. So
and keywords, if you're not doing keywords in dictionary, you're supposed to still put them in strings.
Okay. So well, how do I explain this? Okay. It's 5 minutes to Tom's class. So let me quickly, because this is the same Zoom link that he uses. So let me quickly just, I'm going to terminate this class. Maybe later. Then I will explain it later in the subsequent class, all right? So I promise you, I'll start from here, and then we'll try to implement it, like to say, okay, let's try using a dictionary, and then let's see why this thing works and why it doesn't work, all right? So we'll do that. So thank you everyone for showing up. The recording of this session is going to be up on our YouTube latest by the end of today. So you can always watch it there. All right. So thank you everyone, and we will take it up from here. So please, if you have any question, remember you can always send it to me on LinkedIn or on our Slack. All right, and we will attend to it. So I'll see all of you next week. All right. Okay then. So bye everyone.
Bye.
Yeah, John. Thank you. Bye.